to Twitch for our Cosmology segment. Before we get into that, thanks everybody who views the videos on Twitch, twitch.tv/smAsho. Thanks to our BitChute subscribers, as well as our YouTube subscribers. Please press the subscribe button if you're not already a subscriber to the channel. Press the share button if you haven't shared the video on your social media. Tell your friends, foes, and science noobs and science pros about the channel. And let's do a cosmology segment. Should be an interesting one today. Starting out with the story about LINDS 1523e, the cold, molecular, and starless core. So this blob of molecular material here, known as LINDS 1521e, was recently observed using the ARROW 12-meter telescope. And we're not exactly sure what we're seeing here, but it's not understood how these complex molecules are here. How is it doing this with no star at the core of this area? So we've got some interesting molecular structures in there, including dimethyl ether, methyl formate, vinyl cyanide, and various transitional states. What's going on in this cold molecular cloud? Well, the answer is we really don't know. The detection of a rich, complex organic molecules chemistry in young cold core L1521e represents an interesting challenge for future modeling efforts, requiring some type of unified approach combining cosmic ray chemistry, reactive desorption, and non-diffusive surface reactions, the astronomers concluded. So perhaps check this one out. It's in the phys.org's Astronomy in Space section. And if you want to look this up yourself, you can actually find L1521e, although you won't find very much, as again, it is a dark molecular cloud, so if you're not viewing it in radio frequency and so on, it's going to look dark. So Iris is actually infrared. You're not going to see anything on the 2MASS either. You're not going to see anything on any of these because, again, it's a dark molecular cloud. You can see the 2MASS showing next to nothing when it comes to infrared light. And next on our list is the astronomy picture of the day. So this one's not my favorite. It's an animation. It's an artist's rendition of a black hole tidal event, a massive radio source devouring a star, so to speak. And it's a pretty cool visualization. You can see the torus forming here, as well as the poloidal jets blasting out. It's a model of what may happen during a tidal disruption event when a star has its atmosphere siphoned into the quote accretion disk and quote of the massive radio source, which people commonly would refer to as a black hole. Here's a close-up of what some people think you may be seeing if you were inside the torus, with a fairly close-up view of the quote event horizon and quote. And now a pan up to one of the poloidal jet regions. And next I'd like to talk about the Faraday effect. Are you aware of the Faraday effect? The magneto-optic Faraday effect, where light is affected by magnetism, especially at cold temperatures in a medium? Well, if you haven't heard about the Faraday effect, it's probably something occurring in space. What do you say? Leave us a comment. Let us know what you think about the Faraday effect. Or have a read on the Wikipedia article if you like. Were you aware that light can be stopped entirely? So it was big news when they slowed light down to 38 miles per hour. After that, they stopped light entirely. So Einstein theorized that light cannot travel faster. But what about slower? It appears to not travel at a uniform speed through a medium, especially when associated with a very strong magnetic field. So perhaps check out this article from the Harvard Gazette. The title is, "Researchers Now Able to Stop and Restart Light." So basically what they did here, folks, is they had a laser and a magnetic medium through which the beam of light passes and a sensor. And they were actually able to have light passing through the magnetic field, turn off the laser, turn off the field, and find that light found its way back to the sensor. So light was paused, folks. They stopped light entirely in this experiment. It's kind of serious. And if you weren't aware, we're more than happy to bring this to your attention. They shot laser beams through a dense cloud of rubidium and helium gas. The light bounced from atom to atom, gradually slowing down until it stopped. No super vacuum or ultra cold was needed. In fact, the chamber where the light stopped was at a temperature of 176 degrees Fahrenheit. Only half of the incoming light was stored, and the storage time was shorter. So in any case, perhaps check this one out. It's pretty interesting. And again, the title of the article is Researchers Now Able to Stop and Restart Light. Let's talk about the interstellar medium. Frankly, we don't know what's going on out there. The Oort cloud is a theorized area, as well as the Kuiper belt. It's an explanation for where objects are coming from. Are they outside of the heliosphere? Are they inside the heliosphere? Well, there's a new project proposed, and by the year 2045 or so, we may actually get some answers to this. So check out this article. It's from SciTech Daily, Probing Deep Space with a New Interstellar Spacecraft. So there's a new object about to be, well, in the year 2030. The Interstellar Probe, a new proposed, I guess it's already in development here. The Interstellar Probe will go to the unknown local interstellar space where humanity has never reached before. So this has got some interesting stuff about cosmology and so on, as we don't even know the shape of the heliosphere or very much about what's going on in the interstellar space out of it. Is the sun approaching the edge of the local interstellar cloud? What is outside the interstellar cloud? What does it mean to approach the edge of an interstellar cloud? What does that really mean, folks? And the answer is we don't know. But I'll say this, unique heliophysics and science opportunities along the Interstellar Probe journey up to 1,000 astronomical units from the Sun. An astronomical unit is the distance from the Earth to the Sun, corresponding with about 93 million miles. Another interesting scenario happening here. And what is the shape of the bow shock? What is causing the bow shock? What is the directional aspect of the incoming protons? What's going on in interstellar space? It's a very important question, as maybe it gives us insight into things like heliophysics. Today we're not going to pick a random number at all. We're going to look at a totally non-random object. The brightest intrinsic object in the Milky Way galaxy, at least visible from our solar system. It's Cygnus X3, yes. Here it is in the Chandra X-ray telescope. What we were looking at there was the infrared on the Glimpse 360. How about on Pan-STARRS? Here it is in color. It's a high-mass X-ray binary consisting of a massive radio source orbiting a massive star, a blue supergiant known as a Wolf-Rayet star. And it's a pretty violent place. It's one of the most powerful X-ray sources, and it's one of the only known cosmic ray point sources. And check it out, folks, over the past few days here, the past about 6 days, we saw a very dense series of outbursts once again, and X3 is currently in its X-ray loud state. We're trying to get radio astronomers to take a look at this, as if we catch this in radio frequency during its transitional mode between its X-ray loud and X-ray quiet state, it'll probably give us additional information about the nature of the jet that is connecting all the way from Cygnus X3's poloidal field to your brain. Yes, it's true, folks. It's sending cosmic rays directly through your brain from a disputed distance of somewhere between 2,000 and 8,000 light years. Cygnus X3, the brightest intrinsic object in the sky. The star Deneb, part of the Summer Triangle. And that's today's Cosmology segment. We'll have to say goodbye to Twitch until we return for the Meteorology segment.